Hey, good morning. All right, we're going to finish organizational overlays. My handy highball. Zero sugar. Okay. Um, Fantastic. So, what was I thinking about the overlays? Okay, so the overlays are going to be how we track upstream, programmatic tracking of upstream. So this is basically like your Ruby. If you do or did Ruby, I think was it Rails did Rails have the migrations built in? I think Rails did have the migrations built in. If you did migrations, like this concept, if you're familiar with this concept of like database migrations, um, then you can think of overlays like database migrations for your code, um, so that it always tracks upstream. It applies to whatever policies that you want to like put on that code, right? So you can say, okay, so we're going to put all this information on chains, right? So what is input origin? Input origin is our way of doing input validation. Um, so we track with our lineage. Basically, we track all of the data, and therefore we track all of the trust boundaries. If you have all of the lineage of the data and then all of the operations, then you have all the trust boundaries. So um, yeah, so basically we're going to um, set the origin, um, and uh, like depending on the origin, maybe we would, depending on the parent context. So if we apply the overlay, we might say, okay, so what's the top level system context? What's the caller? Uh, what do I know about the top level system context and how it's similar maybe to previous contexts, either via programmatic match or like via trained model matching or via manually input operations. Um, so um, you could then say, hey, when I'm running Alice connected to this Discord, remember, because Alice is the entity and the architecture, both, right? So when I'm running Alice on my IoT device, maybe a camera or something, um, that, let's see. Yeah, when I'm running, okay, so remember, the whole thing is we're going to let everybody run code on everything. This is RCE everywhere, right? That's the point. Um, so, um, so the name of the game is the sandbox, right? If RCE everywhere is assumed. Um, so um, in that case, basically we're using these overlays. Ruffles, where are you going? We're using these overlays to apply organizational policies which are context aware, which you can basically think of as like RBAC on everything, right? So if you always execute uh, through um, interface, um, this interface being the system context, and some kind of tooling, right? So we're writing some tooling right now. It happens to be DFML implements this, right? But we're going to do, it's a spec, right? And so we implement the spec. Um, and the spec is the open architecture. And that is also what we're referring to as Alice here, because then the first entity that we instantiate using the open architecture will be Alice. Um, so, um, okay. Yeah, so the overlays, they allow us to apply our organizational policies. Fun stuff. So this is what's going to allow us to basically, um, this is like a prioritizer, right? So this is like the prioritizer on kickoff sort of thing, right? So we can use we can use, this is our strategic plans, right? So this is our context of where strategic plans. So this is your strategic plans, which are a part of the data flow, right? These are just part of the feedback mechanisms. These are just part of the strategic plan is just part of the feedback mechanism within the data flow that's not feature extraction. Um, it's a conceptual layer. It's something that represents understanding rather than just data mining, right? Which is the raw feature data. So strategic plans may already be in the architecture if represented as data flow, right? Or if represented as something else. But let's see. So if it's represented as data flow, then you can use overlays to apply more strategic plans because what do? So we load all the overlays, right? We load them all, and then we combine them, and then we pass in the new data flow, and then we run the combined overlay, and we give it the the new data flow, which is the one that we want to apply the overlays to. And then by running this overlay, this merged overlay flow, and passing it, the input being the data flow being overlaid, also referred to as to this data flow, um, then that gives us the resulting system context, right? So this is also if we're doing TBDEX flows and we're trading system context, this is our aligned system context, right? So if we go back to that Bob and Alice diagram, um, if we go back to that Bob and Alice diagram here, I don't, okay, so this one, obviously we didn't finish this. But remember this. Okay, so this is the TBDEX flow overlaid. So we took the DFFML execution architecture. We put one for Alice, we put one for Bob. This is just the default data flow architecture we have right now, right? One execution possibility. And then we combine that with the TBDEX flow. And so what did we see? Well, this is just this is ridiculous. This is just comical. So how do I make this bigger? Um, there must be a way. Mermaid, mermaid. Must be. I think I was just messing with this one. I think I overwrote this one. Let's go ahead and grab this. So I don't want to lose my thought here. I can feel it. I can feel it slipping away. Okay. So what are we talking about? What are we talking about? Okay. Come on. Come on, come on, come on. What's wrong? Okay, well, it's not happy. All right, fine. Okay, so what were we saying? What were we saying? Okay, so we apply the organizational overlays. It's similar to the alignment check. Okay, so basically a new system context comes in, right? Okay, so what was it? Let's look at the TBDEX exchange. I think this might be it. Did they fill this out? No. Okay. So ask PFI conditional offer, Alice condition offer accept. Okay. Ask. Okay. Ask. PFI. Build. Ask. Message reply. PFI. Message. Thread processor. PFI. Build. Ask. New ask for new offer processor. Build. New ask. Okay. Okay. So they're just doing like a non-async version of what we would be doing here. So use ask. Okay, so PFI excuse the ask or no ask. PFI can reply to an ask with a conditional offer. Okay, so we ask for a particular system context to be executed. We receive a additional conditional offer from the PFI, aka Bob. Alice issues the offer accept with the aligned system context. This is the system context which we applied our organizational overlays, right? Um, and we came up with a resulting system context. This is the system context DID. The DID for this system context we place in the source currency field of the conditional offer. Wait a minute. Yeah, come on. Come on, highball. Come on. Source currency that the customer held. But what is this? This is just, look at this. Look at this. Look at this. Two string values. That's not, there's no two string values in here. I don't understand. That's one string value. Why are there two string values? That's not, I don't get it. This is really infuriating. Um, so what up? What up with it? Okay, what up with it? You guys are awake. Let's see. All right, okay. Angie, Angie. Aha. Angie. Come on, Angie. Angie's great. Let's see. I've been following her on Twitter for a while, and she does great stuff. Okay, so 2 days ago, lib. Let me just, you know what? Oh, this is the repo. This is the computer that blows up if you clone a Git repo on it. Okay. Update. Links. Settlement details. Saying. Okay, Helen, can we just talk to you, please? DID. Oh, that's right. There's this contributing for the PFI mock. Yep, I don't think I saw that. Okay. Oh, wait. What other branches are active? Two months. Yesterday, 57. Okay. Lockdown, relative links permanent. What about our buddy? What about our other buddy, Helen? There she is. Okay. Ha, here we go. All right, here's the February 18th. No, okay, where's your real? What's really happening? This can't be right. Where's your real commits? I don't believe any of this. Let's see, TBX protocol. She probably has a private branch, unless she's doing work here. She has a private branch somewhere, or else she's moved on. Active. The most active you have is 2 months ago. What's going on? Make the PFI working on testnet. Ruffles, where did you go? Okay. Offer accept from ALFs to PFI. Do not store bank account in our database. That's hilarious. Um, I don't understand. This doesn't map at all to what the hell is in the code. Okay, here's this. Show me the code. Okay, why are we doing this? Okay, well, it doesn't really matter. Wow, that's really okay. Too much time spent on that. Okay, basically, the point is we don't even have to use TBDEX. It would be great if we could use TBDEX if we could figure out what was going on. But let's see. So if we can use it, so if we can use the ABD, this like Blue Sky, was it Blue Sky social network? It's like this. They have this ADX or something, some kind of protocol for social network based on this DWN, DID stuff. So that could be our primary communication layer. That'll probably also facilitate a review system, I'd bet. And let's see. And then we just use TBDEX for the trades. So that would be what I'm seeing as ideal right now. Let me know if you see anything else. Okay. So okay, apply to the executed. Okay, so what's happening now? Use this data flow. Okay, okay, to this data flow being overlaid. To apply this overlay. Okay. So what did we say? We said, okay, so if you wanted to do, so apply overlay to data flow to be executed. So if you wanted to do, um, if you wanted to reorder the way that the overlays get applied, um, or merged, you would just specify a different, um, you would just specify a different overlay. Like you would just give an overlay instead of loading the default system installed one, right? And then you could just modify this flow. You could overlay this flow to to change it. So to apply this overlay list to this, so we could have a little. All of these I think are none of these are async, right? So this is a data flow which we could go execute. We could just go execute this, right? So we can make something that allows us to execute this statically overlay without the async stuff, right? But the generic case is async. So That's probably something that you would do with an orchestrator. Yeah, a specific orchestrator would do that. Yeah, okay. So overlay apply. Use this data flow. Okay. Okay. Data flow bean. Okay, use this data flow to apply these overlays. So if you had a stream of overlays to apply, well, this is a batch. I mean, this is the batch. Apply, overlay, batch, apply. List of so this is data flow being overlaid, or no, data flow merged. Where's the, oh, that's right, we wrote, did we merged? Why are these both the same thing from dict? Oh, because we haven't done this one yet. To dict. Merge op data flow merge. Okay, so data flow being overlaid. Okay. We need to take this out of here because this is I think that was to illustrate the fact that we could do the named or not named operations. So I don't believe we need that. Okay. I can thank Ruffles for waking me up early today. Ruffles, waking you up early every day. All right. So we'll just call this, merged data flow. It doesn't even output anything. So void. That's so dangerous. Um, that's the most like reckless thing I could have done. Okay. Hmm. Why would this be very bad? Throwing everything into the void sounds incredibly dangerous. We're not going to do that. No. We must have a unique type for everything. There must be a unique type for everything. We're not going to be throwing things into the void willy-nilly. So, because that would we would lose a lot of information. So we gotta really avoid that. So let's say unused um, unused dot. Data flow. Okay, and what did we do? We did this overlays installed, and this is actually, yeah, okay, so this is, the interesting part on this is when we do expand, we're gonna basically disregard the type hint there. So I wonder if we're gonna, because if we say expand, we're saying this thing returns this type. Maybe we should say, yeah, we should say list. Okay, so we should make it, because that would be correct typing information. Okay, so if we do that, then an op expand result. Okay, so then we'll go into base and change that to apply these overlays. All right, so this looks pretty sane. To this list. New type object. Hmm. Yeah, so full to do full auto generated definition name should reflect hierarchy, or let's see, lineage of definition. AKA this thing is a dict. Wait, why is this? This is object. Because data flow type is, yeah, an object. Okay. Use to apply data flow type. Okay. The data flow type as dict. Data flow dot. How do we descend from both? Can we make a new type which is descendant from two types? How do we represent a type transformation? How do we represent a type cast? Um, Cast. What do we want? We want a type cast. Ruffles. Typing.cast. Type file. So, so we could potentially, um, monkey patch typing dot cast to set type on val. Um, so what would that be? That would be the addition of a line between these two, which says val dot typ equals typ. And that would make it so that we would retain this chain of information. Um, so let's go ahead and do that. Um, so data flow dot data. So new type. Okay, so now we're going to say cast cast type val. Okay, so cast data flow type as a dict. Okay. Okay, let's see some usage. Oh, no usage. Cast a value to a type. Turns fine. Okay. So data flow type as dict. We need to make sure that this cast, when it runs, so if you import, okay, if you haven't imported DFML yet, you won't have your correct typing information if we do a monkey patch like that. If we can load the object's source file and do the static analysis ourselves if we wanted to. All right, great. So this is possible. Yeah, we just load the source. What about the event that the source is not attached? Well, we can use inspect on the code object. Okay, but ideally it just has this. Okay, so what happens? So okay, with unit test.mock.patch cast Okay. Hmm. How do we replace something? I always forget. Oh, so we want to replace. Replacement object. Pad. For heart magic block. Okay. Okay. Okay, so we're not going to deal with this. Okay, I don't have time for this. I think that's what that ends up being. So unit test mod patch have cast set val.typ equals typ and val.casted equals true. Or yeah, no, if it has typ, it's been casted. Uh, include parse Python source to do act as sys to uh, type check uh, in the event mock dot patch not addition of typ not available at runtime. Parse Python source retrieved via inspect or frame code. So maybe it's in inspect, maybe it's in the stack frame code. I can't remember where it is. Okay. Data flow overlays merged is not defined. Merged. Data flow after overlays merged. 192. Okay. Okay. Um, so to do document, if you want to, uh, if you want to define the order in which overlays are applied, you could uh, overlay the default overlay uh, to add conditionals or like to, I don't know, somehow uh, ensure iteration over plugins fed to merge is uh, so basically what you would do is you would take that plugins installed um, and you would maybe make it take the merge output as an input, and then that way every time it gets merged, it gets called and it just keeps iterating over its list that it has there that it's sitting on. It grabs that class.load, it saves it as this iterator that it instantiates on um, like on con like on data flow initialization. And so on operation implementation initialization, it opens that iterator, right? And then every time it's called, it just iterates once. And that way, and you seed with a output from merge. Um, uh, you seed with an output from merge. Yeah, and then you also, so you modify the flow. You need to do that data flow.update. You modify the flow. You seed for one of these things to be merged, and then the plugin's installed will accept it. It'll do the iteration. It'll output another one, and then that way you can control the flow. And so you could obviously wrap that in a subflow. So, okay. Document if you want to define the order in which overlays are applied. You could overlay the default. That's just one way you could do it. You could overlay the default overlay to somehow ensure iteration. And to merge is gated. Perhaps take the output of merge as an input to an async. So if we have like an async iterator, which no, it's not like an async iterator because it's like the body of an async iterator. Perhaps take the output of merge as an input to the uh, the operation. So right now we're doing class.load and then expand, right? So basically if you just had a single operation that didn't do expand, right? Or basically if you just didn't set expand, right? Then uh, or and you didn't return a list, right? So you turned a single one, returned a single one, and then you take that. You also take the output of merge as an input. Then you're able to, roll it whatever way you want in terms of whatever the next thing that gets let out for merge is. Okay, hashtag output of merge is one of the outputs to the operation to a non-expanded plugins installed operation. Okay, we'll call that good. Okay, so hideous. Okay. All right. So I think we can safely. Okay. So we'll get rid of this for now, and we'll say data flow overlay apply. And then we pass in the diff main package overlay. Diff main package overlay. Okay, so, data flow type. Okay. Oh, this should be data flow type as dict. And that should be so unused. Data flow type as dict. Just playing around with all this stuff right now. Right, we're going to see where it takes us. More information is good. We can make more informed decisions. Okay. Okay. So this data flow type. Okay, that is what overlay batch apply takes. Okay, so overlay batch apply. Okay, so overlay batch apply. DFFML main package overlay. Okay, so the first thing we're going to do this is why this is so confusing. Okay, so the first thing we're going to do is run overlay batch apply. We're going to run plugins installed. Okay, this is why this is so confusing. This is why this is so confusing. Okay, at least this makes sense now. Okay, so okay, we'll leave this as, this is note just for data flow as just for below is just line with data flow method is just was just for exploring data flow as class method concepts calling concepts. Okay. This is hilarious. It's so simple though. It's like it's so simple yet it's so difficult. Um, I think it's just because you have to think differently, sort of. Let's see. Okay, data flow. Or maybe I'm just doing it wrong. I don't know. It took me 3 years to figure out the output operation thing, so quite possibly I have no idea. Um, so okay, so this is the trick. So basically we run the batch apply. Um, we run the batch apply. What do we apply? Um, data flows being overlaid. List data flow to apply as overlay. So how could we do that? If we see list data flow to apply as overlay, what will that do? I think we need to patch base for that. List list. It's in the where is it? Df well, df base. Here it is. It's in this create definition code. So what time check? Okay, 6:20. All right, so definition data flow type. Okay, so list. Okay, if the annotation is formed, list my data class. Okay, primitive array inner class. Okay. If inner class and primitive types, what won't be? Okay, if is data class otherwise, we're gonna fall through. We fall through this thing. This is why falling through is dangerous. Name. I think if we do this at a minimum, we should be good. Because then we have the typing information, at least in the name. And what was the other one that we did? Okay, that was the other one. Okay, so definition data flow. Okay. What does this translate to? This is like class call caller inputs. list class color input. So you could call these whatever you want. So you could say class color inputs. List data flow being overlaid. Okay, so you can take this allow list and you can generate a function signature. So if you can take the allow list, there we go, for data flow as class method. Take the flow from seed origin dot data flow, so data flow allow list. For data flow as class method, take the flow data flow. Take the flow from data flow allow list. Okay, so for how do we do data flow as class? Well, we run the data flow through something very similar to an overlay, and the output is a class. And okay, to create the data flow as class, run a data flow on another data flow to produce similar to how we do overlays, to produce the class itself, class object. Okay, so okay, method signatures correspond to different deployments labeled with different method signatures to correspond to operations within each flow. Okay, so you can just call, yeah, okay, so each operation becomes a method. Okay, each operation becomes a method, perfect. All right, and then you can have an operation called another operation, right? So, or trigger another operation, so you could have trigger a whole subflow or something within the parent flow again. Okay, so invalid syntax, and since it's a lifetime of the class, you might have another method called another place, and then they're interacting with each other. Okay, so okay, so there might be other method within the data flow as class, double context entry. Okay, so basically we take this main package overlay, we overlay a data flow, we overlay a list of data flows, the only one in it being this plugins installed. right, which will be the source of our and the source of the other classes, which the data flows which actually get applied in the next one, right? And then we run this next one, this overlay batch apply, and when we run overlay batch apply, okay. Okay, so here's the trick. So we don't want, yeah, list data flow to apply as overlay. So don't expand it, basically. We no longer want to expand because we're doing a batch all at once. Okay. So return a batch of overlays to be applied. The batch is given by searching the dfml.overlay entry point for installed overlays, installs registered overlays. Okay, so okay. Okay, so first take this main package overlay, which is basically just what does it do? Well, it just whatever you put in there, it overlays and applies, and tell it, okay, well, we want to, I want a new version of that data flow with plugins installed in it. So then we run that, and so we could do this statically. So we'll say to do this flow could this first flow execution to create the main package overlay with plugins overlays. Overlays installed as an operation which is the source of the data flows to apply as overlays. Okay. So dfml main package overlay default. So, or maybe installed. Okay, right. Maybe this is dfml overlays installed, right? I take quick break.